Hello students, and welcome to the pre-lab video for the acceleration due to gravity. You know, if I had a small object like this ball here and I dropped it near the surface of the earth, well, we know its speed will increase as it goes towards the ground. And if we assume the acceleration it experiences to increase that speed is constant, and we knew this distance and we could measure the time it took between when it was released and when it struck the ground, we could easily compute a value for that constant acceleration, and we would call that acceleration the acceleration due to gravity. Well, we could easily measure the distance with, say, our meter stick, and perhaps use a stopwatch to measure the time of free fall. But it would be a little difficult to get the time measurement accurately that way. I'm going to show you a device today that we can use to very accurately measure the time of free fall for this object. And we'll use a photogate timer with a free fall adapter. And it will give you a very accurate measurement of time, but you have to know how to use this piece of equipment correctly. So let me show you here. So this is the piece that will initially hold the ball before we release it. And it consists of a flange type side, and then there's this post that goes through and a little set screw. And if you do not know how to use it correctly, it can be frustrating. And I'll show you how to set it up and how we will initially mount the ball in this device. So once the ball is mounted in this device, the timer part of the apparatus is set to 0, and when the ball is released, it opens an electrical circuit that starts a timer. And then when the ball strikes this pad at the bottom here, ends the timing, and we get an exact measurement for the time of free fall. But it can be a little challenging to put the little sphere into the device correctly. So let me give you some hints here. So we want to push in the little pin here and make the gap a little bit smaller, a little bit less than the diameter of the ball. So we press it in there and then tighten down the set screw. And once you get it like that, you can push the ball in here like this. It's important to get it just right. And it will stay snugly in there like that. And then when you release the set screw, it will fall. So you would mount this to a lab stand like so. I'll demonstrate this. And you would want to make sure you have it directly above the little pad. And now when I release the set screw, the ball will fall, it will start the timer, and I will get my measurement. So let's try this. So if you look at the photogate timer, you see it has an on-off switch and a reset button. So we want to hit the reset button to make sure we're back at 0. And I'll just see if it works here. So when I release the ball, it should start the timer, and it should stop when the ball hits the pad. So here we go. So you see it indeed worked, and I got a measurement of 0.331 seconds. So to get a really good estimate for the acceleration due to gravity, obviously we would like to repeat this measurement many times. So I'm going to do that here, and I'll show you that it's highly likely we'll get a slightly different measurement the next time. So we would want to make many of these time measurements and ultimately many estimates for the acceleration due to gravity. So I'm going to repeat it. I hit the reset button, and again I release the little ball, and I get the same measurement this time. Sometimes you will not. So you would want to repeat this maybe 5 times, and then a good thing to do is change the height, because you would measure the height. That's part of the data that is required to get the acceleration. And maybe do 5 releases at 3 different heights, and that would give you 15 values for the acceleration due to gravity, and then you could take the mean of these as your best estimate. So the free fall adapter, a very useful device for measuring the time of free fall between 2 points, and if you use it correctly and use the tips I've given you today, you'll have no trouble using this in the lab to eventually compute the acceleration due to gravity. So that's all for today, and we'll see you in the lab.